But
But nobody knows how long North America is, or South America. Nobody's ever driven it.
No, of course not.
I don't get your
Oh,
argument. No. It's not like you're saying, look, I've measured this. It goes against your map. You haven't done any of that.
Yeah, we have. It's been measured.
Who's measured it?
People that are qualified to measure it.
People? What people?
Surveyors. You know damn well who.
I don't know who. Do you know who?
If you can put your head in the sand and pretend like the world isn't going on around you, and you just live in a hole in the sand on the beach, but there's life going on around you, you know?
Well, put the evidence in the hole, and I'll have a look down there.
Kimmer, who's on first?
On where first?
Who's on first?
What do you mean?
What's on second?
Who's on first?
But Tony, the idea is that because no one's making measurement.
People make measurements every day, Kimmer, when they drive in their car and they look on their odometer and see, how far they travel. And they look up to see how far
long the road
how far
is.
the next city is away.
No,
and then they say, "Oh, look, I'm going to run out of petrol if I don't fill up."
The roads are not straight like
all
the
the time.
Romans. They're not Roman.
What's the difference between the road?
They're not Roman roads. They are weaving and bending, and they go up and down.
The distance written on the map takes account of that, Chemo.
No,
so if that didn't
the
match
distance
the
of the road, not the distance to A and B.
I know when I started my trip, the sun was on my east side, my right side. And when I got to New York, it was on my left side. So I know I continued in roughly a northerly direction the whole way.
Yeah, you're not getting straight A to B measurement drive like that.
So now that's a new thing. You have to be A to B measurements. That's great.
Yeah, to work it on
it's amazing how you guys can keep alive. You guys keep alive just by doing all these nitpicky little semantical bullshit.
Look, you can take anywhere in America, drive in a triangle, and that triangle will add up to 180.
By the way, the roads that I drive on
no, it doesn't.
Take
the roads that doesn't though, because on a globe,
three sticks of any distance, as long as they're equal, and they will always be 180. That triangle.
But they don't though.
The roads I drive on going northbound in the U.S. when I'm going from North Carolina to New York are relatively straight.
What you're not getting is one of those sticks has to be on the horizon to give it the deviation that you need. And we know that because if we take a stick beyond the horizon, it will not deviate or tilt or give us anything but a parallel measurement to the other sticks. They'll all be parallel. Okay. And that's where you guys have the problem. Because without geometry, then there can't be any globe.
If you can just show us where you got those measurements from, that'd be great, Kimo.
Well, you can just put any triangle on water. That triangle will always be 180.
Did you see, like a minute ago, you were demanding us to have measurements, but now you don't have measurements. Are we supposed to believe you? Why are we supposed to believe you?
So we put a triangle that floats on the water, and we make it bigger and bigger. At what point will that be more than 180?
It'll start getting 180 as soon as you start moving it.
How?
It's just going to be microscopic, but it'll start deviating. It'll start adding on to the 180. I think the more it expands, it'll expand, and the more the numbers will go up. That's the way I see it. I don't know. I could be wrong, but
of course you're wrong because you can make that triangle.
I don't think I'm wrong though. I don't think I'm wrong.
Make that triangle as big as you like, put it on the ground, and it will always be 180.
Okay. Not if you have great measuring tools.
Now, let's say we can see 2 points of the triangle, left and right of us. Third point is beyond the horizon. That third point, even the 2 points that are next to us, we can look left, right, and we can see those 2 points. But the third point should be angling away, which will give you your excess. But because
they'd all be angling away.
No,
they'd all be angling.
No, it's not. That's the whole point. Because these are not angling away, you can't have any excess.
I mean, how it's gotta be so difficult to wake up in the morning and be like, okay, now I gotta propagate this lie to me today too. You know what? I'll say there's no such thing as over on.
Have you never seen them boomerangs that are a triangle?
Oh my god.
Now imagine a giant one of those. That's never going to be more than 180, is it?
Actually, they're one angle.
Just one angle.
Triangle boomerangs.
There's no such thing as triangle. There's one angle.
Yeah, there is. They have it.
Yeah.
There's one angle, and
okay,
if
I
it
don't
was
know
ever
about
more than 180, it would
Not
just
a
be less than
boomerang,
180 again.
but
That's why they fly back to
a
you.
triangle boomerang.
Oh,
But they're not triangular.
It's not It's technically not a triangle. It's just a
No.
line with an angle
Oh,
in
I'm
it.
thinking of a triangle one.
No, they
Probably
have
not.
triangle ones too. They have ones that are closed off.
But anyway, the idea is that you
Yeah,
take
probably
any
do. I've never
triangle.
seen one like that, but they'll probably do. Yeah.
The
Oh, you're talking about the ones that are like three.
The Nerf ones. Big ones.
Yeah, they have like three pokes in it. Yeah, but those
Hey,
aren't
Anarchy.
triangles either. Those are.
Anarchy,
What are
check
those
this
called?
video out. This is a good video.
So, is it possible
No, but
to
it's a
show?
bad example. It's a really bad example.
How
That's
can
all
we-
I know.
Wait,
How
Kimo,
can we show a triangle then?
Kimo, what's the name of that shape, Kimo?
What?
The triangle with three. It's not a triangle, but it's like a star.
Can't remember.
With
Yeah,
three
probably a
pokes?
star or
What
something.
would you call that?
Yeah, it was something
Like a
like
cross
I
with
can't
three
remember
pokes.
that. Yeah. Oh no, yeah, I can't remember. But the idea is we do not have a triangle adding up more than 180. If we lay it down flat over the water and extend.
But we do.
How?
Ask the geodetic surveyors who do it every day. I'm sure there's someone out
Talking
there right
about
now
a physical
surveying
triangle.
something.
A physical
I'm sure there's
triangle.
someone out there surveying right now, Kimo. Why don't you talk to them?
Oh, we have. We've been
No, you have
speaking to
not.
the surveyors, and they say level is horizontal.
No, that's not a real surveyor.
No, you can speak to any surveyor, and they will tell you, yes, level is horizontal.
We have, and that's bullshit.
No,
No surveyor would ever say that because they're not dumb enough to say that. They're not stupid enough to say that.
no, level is horizontal.
Bev isn't a surveyor.
Seems like every surveying book ever written contradicts you.
Show me one survey that says level is not horizontal.
Surveying books.
Any real surveyor says that.
No, because
I'm
when they
sure
say-
the people you talk to don't. You're talking to a bunch of crackpots, Kimo.
no, I'm talking
Crackheads.
about the surveyors when they want something.
Yeah, what surveyor have you talked to that's not a fucking crackpot?
Oh,
For real,
we've spoke to many surveyors and stuff over the
Give us
years.
one name then.
Name one.
Give us one name we can check on.
Main surveyor.
Give me a name. And
Well, I didn't
phone
speak
number.
to him, but our
Mhm.
community did, and yeah, he can show that this is a presuppose this excess that they use.
That's
There you go, Kimo, in 10 minutes past the hour from a survey book from 1915 showing that
Oh my God.
flat and level are different.
there you go.
Yeah, these days they were trying to figure out if the Earth is a ball or not, or what we can do to make sure we
They already-
know it's a ball.
They already figured that out like way before 1915.
No, Tony, I've got a citation from the CIA that says the shape of the Earth is.
Stop changing the
is-
subject. We're
is
talking
not
about
known.
surveying books. We're talking about surveying books, Kimo. We're talking about surveying books. While curving, line CF is a level line through point C.
CIA are surveyors now, are they?
Then, remembering that point F is at the same level as point C, we get a total difference of elevation between the 2 points.
Yeah, I know. I'm saying
So-
all in those days they were like.
While
okay,
curving, line CF is a level line.
Think
You're
about
saying
it.
that surveying has changed since 1915, are you?
1915, yeah. So that's the same year or same time that Einstein came up with his equation. So they were really pushing the globe, and they were changing all
God.
definitions to
You
fit
said
the
that no
globe.
surveying book. You said no surveying book would say this.
No,
but they've been
I
saying
mean,
it back
you
since
said 1915,
1915.
so that's understandable. Yeah.
Okay, we'll find you one from 2019. How's that?
With that, well, obviously after 1915, that was the definitions changed.
How?
In those
you
days,
want to find that?
remember,
Okay.
in those days, they were
We've
really
got-
trying
Hold
to
1915.
fit the
We
narrative.
got
If you've got a
we
narrative,
got
you
surveying
need
books
things.
from the 1700s that say that, Kimo.
Yeah, that's what I was thinking. Do you want to go back a bit further?
You guys said
Level.
ancient times. That's when everyone knew everything was back in the ancient times. That's the only time that our civilization was smart.
No. We've got a paper from the 40s where the shape of the Earth is not known.
Okay, well, we know it now. They knew it then, too.
How can we know it, Tony?
There's a horizon. I look outside, I see a horizon. Boom, that's curved. Bam, I went.
Bam. That horizon's not physical, geometrical. Bam, bam. Now what?
It is physical. Hey, if you're looking at it, it's physical. Why don't we even have this argument with you?
Yeah, you look at
If you see it,
but it
physical.
fluctuates, dude.
How can you see something that isn't physical?
It be fluctuate. You understand the word fluctuate? Let me get the correct definition for you.
I don't want the definition of
Yeah, because
fluctuate.
obviously sometimes when we read things, Tony, it helps us to understand clear.
Exactly. Maybe you should try that. Horizon, horizontal, not level.
No, I'm gonna get you the def. Don't worry. All right, let's take a look at this. Okay, so all right, you're gonna like this one, Tony.
Yeah, I'm sure I'm gonna love this. This is gonna be
I'm here
great.
to
Fluctuate. Moves around. Goes different parameters. Whatever.
I'm here to help.
Yeah, thanks a lot. It fluctuates. It's still there though, isn't it?
Fluctuation. About it right.
I get the word.
But we understand how it fluctuates though. We have equations that describe the fluctuation. We know if it's humidity, a certain amount of humidity here, and a certain amount of temperature there, it's going to make this much fluctuation. We already know those equations.
Check this out.
I don't want to.
This is the definition of fluctuation, right? Look what it says. It says,
What's the definition of fluctuation?
yeah, because sometimes when we don't read these things, it's difficult to
Flat
digest.
Earthers' arguments. Flat Earthers' arguments.
And a regular
Fluctuation should be down there somewhere.
Difficult to digest. So look, we can
A
see
variation.
we can see variation, shift, change, alteration, swing, movement, oscillation.
And we can actually describe those in numbers.
Yeah, so it's an irregular rising and falling. So you've got this horizon.
What's the relevance of this?
Now we have
What's
the
the relevance
definition.
of
It's
this?
clear for our eyes, right?
We did it at St. B's, remember? Chemo, we were there. You guys were there at St. B's, and we described it to you, and you guys saw it. Now you're saying you don't know what it is?
No, I'm just saying that because the horizon fluctuates, and it's variating, it's shifting, it's changing and altering, yes?
Fluctuation. Yeah.
Then you can't measure something that is constantly changing, Tony.
Yes, you
Why
can.
not?
You can measure it easy.
Why not? Why
How?
can't you take? Okay, you can take an average of
Mm.
what the horizon is showing you.
Average? We're talking about the physical geometric location.
Shit.
Horizon. There is no geometric location of the
Excellent,
horizon.
excellent. Welcome to Flat Earth. Now, who's next? Where is
Oh my
that
God.
physical?
There is a location. It's just, you know, I mean, it's hard to get there. You'd have to have someone go put a stake in the ground and be like, okay, the apex of the horizon is 2.7 miles away. Now you mark off 2.7 miles away, and because we know the radius of the Earth, so we can't find the metric.
The radius, unfortunately, is assumed, Tony.
Okay, you assume everything, don't you? When you wake up in the morning, you assume you're going to get out of bed with your left foot first. Everything is an assumption.
No,
Until you make-
don't be silly. That's
Yeah,
silly.
yeah.
Yes, you do. Of course
No,
you do.
you don't. You wake up, you say,
You
right,
make an assumption that you're
getting
not
up,
going to die
I need the
every
toilet,
single day.
I'm going to make a drink, got to brush the teeth, all these things. So it's not
Tell me
assuming.
one invention that
You have
hasn't
a
been made with
pattern.
an assumption first. That
No,
has
you
not
have
been
a
made.
pattern. You do the same thing. Wake up, you get up, need a drink. Or
Isn't hypothesis just another word for
Hello.
assumption? Pretty much.
what?
No, I don't think it is.
Isn't there
It's
something?
close. Somewhere down there. Somewhere down there.
Alright, so TT guy, what do you got here? Let's
Maybe
have
on
a
the
look at
10th
your
the 10th,
image. So look,
10th,
this is what I'm trying to explain to you, TT guy, is that these physical places, they fluctuate. Alright?
Horizon is a physical place.
No, but you
That's
see what
what you're
TT
telling me.
guy's done. He's made some.
We're not talking about that. You've moved on to fluctuation to try and obfuscate your lie before. We were talking about the definition of level, and you said that surveyors never. It's a straight line, but in each one of these examples, it's a curved line, and some of these are from modern surveying books. So where are you going to go now?
I've just said
You
to you from
disingenuous prick.
1950. Oh, show before 1900s level meant something else.
No, it
I never
didn't.
said it does. Meant the same thing since the beginning of time.
No.
It means a plumb bob. If you have a plumb bob, level is with a plumb bob.
It's your position, Chemo, that it's changed. You show me that evidence, not me.
No, you just told us.
I'm showing
1915,
the evidence
definition-
that it's not saying that level is not a straight line.
Yeah, but you
it's a
already gave the
curved line.
definition. Oh, you already gave us the year 1915, right?
And then I found some more that are not 1915. It's your assertion that
Before
it changed at some
1915.
point.
Is it
Do you
before?
not
You're saying it changed after.
You're not-
You said it changed afterwards.
No. I'm saying around
Now
that
you're
time.
saying it changed before.
No. I'm saying
Do you
around
not
that.
understand? Like I see in this. Do you not understand, Chemo?
Mhm.
Like if you're standing, see in I think TT guy put this in. It's a great little
Yeah, I've got up the big screen here.
picture
Yeah.
there. If you're standing at point A, right,
Point A. Yeah.
your horizon line
Mhm.
goes out in straight lines, like point H and point D, right?
No, your horizon line is where your tangent point is. Yeah.
No. Well, there's a line of sight as well.
No. We're looking about the tangent point that you would draw from you to the physical geometric horizon, which is in TT's guy's image, but he hasn't
Anyway.
drawn.
You would be at
Anyway,
point A.
we're not
Level
talking about
tangent.
horizons. We're talking about your point about trying to say a level line is straight. And you said, it's got to be before
Oh, you found one.
1915, and there's 1853.
Oh, that's a good one. Yeah.
So where are you going to go now, you disingenuous little shit?
No, I mean you've pulled it up.
Nowhere. Okay, we win. Yay.
No, because we know the Earth is not a ball. But all this is just to support the narrative. But it's a good fight.
Victory
No, I
is
concede that you've got
So
information
the
before
assumption-
1915.
Did you lose? You
You
loser.
won. You already won. You won all the Smarties, man.
With the assumption that it's flat or it's not a ball. Okay, well, you're making an assumption there.
You have to
Here's one
make an
from eight-
assumption somewhere.
Here's one from 1814. You know, MC Toons collected these. Well, that link didn't work very well, did it?
No.
Yeah, I mean, look, it's got the
Not found.
56 here, 3959, whatever, and it's got his radio. Again, you've got your radio.
Well,
Everything here is
about-
based on assumption. Read your own thing here. They've got the so I'm telling you, I'm explaining
can
to you
I
when the
say-
idea was to bring up a radius, bring up a narrative. They started to change the definitions.
Well, I often oh my god, I can't believe how similar that is to the current drawing it is, TT guy. What?
Yeah, it's amazing, isn't it?
It says
Haven't changed.
it tells you exact radius equals to 39.
We're not talking about radiuses, Chemo. People have noticed.
Oh my-
you just
No, but I'm
my
saying that
God,
your
it's not
definition is based on a
drawing.
presupposition, isn't it? It says, what does it say in your article? Oh, it doesn't mean it's a level.
Level is not a straight line, you loser. Level is not a straight line, you fucking
Look,
loser.
it says a plane
No, it's
surface.
not.
So they're telling you it's not a plane. So they've already set the narrative up. It's all here in your article. This is setting people up for the idea that
True level is a curve conforming to the surface of the Earth, as in A, B,
if you
G.
presuppose you're on a ball, yeah, with forces.
1814. You said it changed. You said we got to go back before 1914. This is fucking 100 years earlier.
No, I know. And then
You
that was
fucking
when that's when Newton.
You know nothing about this, do you? You know
This is
nothing
when
about this
Newton
subject.
said it was a force
You
of
know
gravity.
nothing about this subject. What a
Yeah,
fucking
you've got no
loser.
idea what
And
you're
it is.
talking about.
And it is. I measure the force of gravity all the time, Kima.
No, Einstein superseded that.
Measure the force of attraction.
All this is just a narrative, TT guy, to support.
Yeah, all
it
this
says
is
here,
that you're a fucking loser.
it says
That's what
a
that proves. You're
globular
a fucking
figure
loser.
of
You got
the
no
Earth,
idea
a
what
level
you're talking about.
surface is not
You
as it
sucker.
appears to be.
You dumb shit.
There you go. It's not as it appears to be. So they were trying to tell people, look, it's not as it appears to be. We're telling you it means curve.
Level is curved. They've known it since 1814.
Yeah, that's the narrative there. So they knew it appears to be a
Other
plane
than that,
surface. They knew back then in 1853 it appears to be a plane, and everything beyond that is a presupposition.
No, see, way before that, we were making globes, and they were telling us that.
Here's an idea.
So
Yeah,
look,
yeah.
I'm going to keep this article because they tell us what we tell you. It appears to be a plane. A plane surface.
Got an idea.
Yeah, well, no one's
If we all cross,
arguing
our
that.
fingers and agree with you, Chemo, would you go the fuck somewhere else so we can have a decent conversation?
What, you want to get into the gravity thing, do you?
No, he wants to have you
No,
not
I just
speak.
want you to shut up.
Go on then, what's your point?
We're having an interesting conversation about seismology there earlier.
Yeah.
That doesn't prove the shape of the Earth, though, Terry.
Absolutely
And
not.
other
Right,
things and more. Debate flat Earth and more.
Yeah. Well,
And as we established, it does prove the shape of the Earth.
Chemo, if the radius is 6,378 kilometers, yeah, isn't that like a pi r square thing that gives you the circumference, you know? And, you know that R and target, yeah, is what you take the measurements from, because the target is always taken from the center of the Earth. Do you get me? There's your radius. You always take your radius from the center.
So in order for level to mean curved, you need gravity. And because you don't have that force,
your mass.
it cannot mean it's conforming to the forces that are acting on it.
Own gravity creates its own gravitational field, yes.
Well,
It's called the magnetosphere of the planet creates it.
you can use downity if you want, but downity doesn't appear to be uniform across the globe. It seems to always point towards one location.
Level mean curve means gravity. That's what you're telling us. So without that force,
we have a
to bend that level line
meets the bloody land, don't we? So if you go into space, you don't have an horizon, do you? There is no up or down. But you can use a planet as an horizon line and try and work your way out from that. But, really relative. Space and vectors are only like coordinates on Earth that we use. It's like nothing else, really. Do you get me? It's not really useful anywhere else. It's only useful to us on this planet. Do you get me? On this big ball, that we've got here.
The angle of downity changes as you progress away from a start point.
No, that's the point. That's the narrative point.
No, I think I was talking.
No, your angle of perspective changes.
The angle of downity changes no matter where you are on Earth, and it keeps on or they keep on deviating more and more.
Yeah, that's the idea. But that's
the observation.
No, that's not the observation.
That's the observation.
So look, let's not argue over silliness. You don't have evidence of gravity being a force. You can't show that beyond the horizon the Earth is dropping.
Visually, from looking at stars and looking at land measurements, downity is different.
There is no downity. Things move in any directions. Gas moves in all directions.
Plumb bobs. What does a plumb bob do?
It depends on the medium it's in.
Okay, what does a plumb bob do in our medium?
Well, it goes in the direction that we would call down.
Okay, and all those downs diverge.
That's not down, it's relative.
All those downs diverge from each other.
I just said that's how we call down. It doesn't mean there's a bias down.
But everything falls down. So there's no bias, but everything does fall down.
No, because if I change the medium, it will go in a
I don't care
different
about the medium. We're in our medium. In the
right,
air
so stop
medium.
saying down then, because there is no down. If I keep saying that then, why do you keep repeating down?
Plumb bob will point towards one straight up and down. And now when you compare all those straight up and downs together, they deviate from each other.
There is no up and down.
Diverge.
Gases move freely in all directions.
That's fine. We're not doing gases.
Right, so it just depends. So why does that happen? It happens because of the medium.
On a fucking string.
Right, and if you change the medium, you get a different effect.
Nope.
Why is power muted?
I can do that through most mediums, and in case if I did it in mercury, it would invert itself and it would go up. But nonetheless,
well, that depends.
It would still establish up and down.
No, because we can make it go in all directions depending on the temperature.
Nope, you can't.
Yes, we can. Change the temperature on one side, and it moves. It moves. Why won't you let me speak, Moyuk? Keep on over talking me.
I thought that's the environment you were trying to set up.
No,
that's how you act.
No, it's not.
It's what you were doing to me. You talked to me several times during what I was saying.
Letting you finish.
No, you did not, cunt. But fuck you. I won't talk to you.
I didn't mute you, by the way. That wasn't me.
Why is Tao muted?
None of your business.
Why is Tao muted?
None of your business.
I didn't hear him being rude.
What does that have to do with you?
I'm just wondering. Got nothing. I mean, you're God in here, so I guess there's nothing to do with me, right?
Nothing to do with
Demon.
you. I don't know who muted
Demon.
Moyak. It's nothing to do with anyone else, is it?
I'm talking about Tau, not
But I'm
Moyak.
just saying, it's what does it have to do with anyone? That's not the conversation, right?
Well, could you unmute him, please?
Of course.
Thank you.
Oh, he's unmuted, yeah.
Thank you. Every time I seem to get one up on you in a conversation, Chemo, I disappear off the mic. Now, what game are you playing?
Look, I want to focus on this downity that Moyak keeps on insisting is a real thing. Now, there is no bias downwards, as I keep explaining. That means if there's no bias with the gases, there's no bias with your plumb bob. All it means is that it's relative density at play, and if you change the medium, the temperature, that plumb bob will go in any direction, and that can be controlled.
But don't use me as a straw man to win your battles. I'll try and help you win your battles, but if you play against me, I'll play against you.
So you understand now, Moyak? I've muted you. I don't know who muted you, by the way. But you weren't being silly, Billy.
Fuck you.
Point was, you're not grasping the concept. And
Fuck you, I'm not talking to you.
And the practicality of it. Is that we need a force for the downward bias. Now that force, none of this makes sense unless you understand relative density. Which has been...
Hey, are you a world champion weightlifter, Chemo?
Have you ever
lifted weights?
Yeah, if you change...
Have you ever lifted weights?
Well,
there's no force holding the weights down, is that what you're saying?
We were talking to Jazza this morning about elephants on top of one another. And I was at the bottom.
When you lift up something, are you overcoming a force when you lift up a barbell?
No, you're overcoming the relative density.
Well, it's obviously a force.
No, there is no force. You will create the force if you're going to use your force to try and lift it. That'll be the only force at play here. Actual fundamental force. Not a fictitious pseudo
equal
treat it as a
forces,
force, an actual force. That's where we are scientifically.
Anyway, yeah, it was interesting how Big Blue was able to build his own seismograph unintentionally.
With the Cavendish.
Yeah. I guess it happens when you have sensitive equipment.
Well, no doubt, yeah. I would
the Cavendish is famous for being dodgy with cars driving past and things, isn't it? Very sensitive to vibrations in the room, what have you.
I would say so, yeah. That torsion's that sensitive, it would pick that up, yeah. No doubt.
On a minute scale, maybe, if you have sensitive enough equipment, yeah. But, otherwise, no. Don't worry about it.
Look, guys, we are devastating. This is not our fault. We were just able to use the brain in a way...
Devastatingly stupid.
How so?
We've got no idea what level means for a start.
Yeah.
Level means gravity in your world.
What? How can level mean gravity? Come on.
Well, I mean, anyway, I don't know how you think that saying gravity doesn't exist means you win an argument, because it just only shows you're a moron that say gravity doesn't exist. Do you ever walk up to someone and say gravity doesn't exist and expect them to not laugh at you?
And then say...
It just means I'm digging deeper in the thought process and understanding if there's no force...
It means you're a cretin.
We can use
Do you go down the street and say, hello, my name's Chemo, I'd like to introduce you to the fact that gravity doesn't exist. See how many people laugh in your face.
Oh, no, we wouldn't drop it like that.
Have you done that on your street activism, Chemo?
No, we wouldn't drop it
yeah,
like
he
that.
has actually. I've seen that happen.
No, but we wouldn't drop it like that.
There's one video of Everett's where he's talking to three
tell them
guys in the
straight
street
up,
and they're telling him, you're a fucking
force,
idiot.
And then they'll be like, what you want about?
Yeah.
And then we hit them with Einstein.
He edits those ones out, doesn't he?
I'll find it for you.
Oh, yay.
Well, what we do is we explain that it's not a force. Then we ask us, what is gravity?
I haven't done a Chemo numpty clip yet. Everyone wants to submit any Chemo numpty clips. That'd be good.
It's funny. Chemo says that plumb bobs will be will not work in different mediums. There's only one medium that it won't work in, and that would be a neutrally buoyant medium. All other mediums, the plumb bob will work.
Well, that depends. What is that osmium?
Work in all mediums, except for neutrally buoyant medium.
That depends.
No, it really doesn't depend.
Yeah, it's relative, so it depends on the object or the medium.
No.
Yes.
Only neutrally buoyant would not work.
Buoyant requires gravity once again.
No, buoyant is an effect that we see.
Because of gravity.
Well, that's true, but then you're admitting that.
No, because there's no buoyancy. Not its density. Relative
Oh, buoyancy
density.
doesn't exist. Okay.
No. It's density. Relative density. That's all it is.
Even relative density.
Every object is subject to relative density.
Even in relative density.
What?
What if you go with that? To the people in the room I'm talking to, Nakimo. What if you go with his relative density? Where does that leave him? How does that affect the argument about the shape of the Earth? What does it do to their claims that water cannot bend around the exterior of an object? Well, if the water is denser than the medium, it's going to go down around the Earth. And this is very simple. I don't understand why you guys get led around by the nose.
But it would fall off the bottom.
No?
Yeah.
No, your relative density has you towards the surface of the Earth.
Not a force, though, relative density.
Unless you want to assert an external force, then maybe. But if you don't want to assert an external force, it will go to the densest medium. The densest medium is the ball.
Timo, how do you measure or how do you measure or calculate the density of a bow?
That doesn't make sense, Moyak. It's not an attraction.
Your plumb bobs are still going to go down, aren't they, under relative density and be non-parallel?
Just is what it is.
But so, Kimo, when you want to think about whether a boat will float or not, how do you calculate the relative density or the density of that boat?
The boat?
Yeah.
Well, the boat's full of air, isn't it?
Yeah. So how do you calculate the density of the boat?
Got an equation for it, relative density.
I'm asking you, like, how do you know the density of the boat?
Because you want to predict whether the boat's going to sink or float.
Yeah.
Which we can do, by the way. You can make a boat. We'll tell you whether it'll sink or float.
We'll even tell you how much it will sink. Like, assuming it'll float, we can tell you how much it'll float by.
It's the same with a submarine. It's the same with a submarine.
Yeah.
It's the same principle.
So can you tell me how do you calculate the density of a boat?
No, you just increase the density and it will sink. Reduce it and it will float.
Yeah, we just take
Can you tell us the density of the boat?
It depends on how big the object is.
So if I give you the parameters of the boat, can you tell me how much the density of that boat is?
Out, right?
I'm trying to see under you because you said that you know this stuff. So
No. I mean, again, these we don't deal with the mathematical construct of things.
So you don't know how even to know anything about the density. You just want to claim stuff about it.
We've given you the practical demonstration so you can calculate it.
No. We've given you the mathematics that can predict what we'll then see in a practical demonstration.
It doesn't work like that. You're doing it backwards.
It absolutely works like that, Kemba. That's exactly how it works.
You're calculating
we do some maths
first
and see if the boat floats at the level we said it was going to, and it does.
You're calculating it first and not even doing a practical demonstration. We show you the practical demonstration.
Exactly, that's why science works. That's exactly right.
The reason you can't concede about how to calculate the density of a boat is because then you get to the conclusion that relative density cannot be the answer to this.
No, that's how a submarine works.
Can you at least tell us how you calculate the density of a submarine?
I don't need to. We've got the practical demonstration.
So you can't tell me anything about the density of any object?
I wouldn't need to know the calculations. I would just need to release the water or let the water in. That's it. If
But
I'm
see,
going
that's
up,
that's
So
that's
going
where our
up,
model works.
then I know
That's
that
where
I've
our model
released the
works
water.
better. That's
all
where
right,
our model works better, doesn't it?
how about this then, Chemo? Can you tell me the density of a neutrally buoyant submarine? So it's completely neutrally buoyant underwater. It's just staying there. Do you know the density of that?
The density of what? There's no
A
forces
neutrally
acting.
buoyant submarine.
Something just floating on top or in the middle of the ocean or something, right?
It's in the middle of the ocean and it's staying there. It's
under the
not
water.
rising. It's not rising. It's not sinking. It's underwater. It's not rising. Not sinking.
Yeah, then what? There's no forces acting on it right now.
So
It's always
what's
at
the
force.
density? So what's the density of it?
What? It's in equilibrium. What are you talking about?
Yeah. So what's the density
Of what?
of the submarine?
What do you mean, what's the density? It has no weight now, it's in equilibrium.
So if it has no weight, it's got no density?
Well, again, it depends on the size of the submarine.
So you're saying it depends on the size of the submarine. The density depends on the size of the submarine.
Yeah.
So if it's 100 like centimeters versus 100 meters, you're saying there would be a difference in the density, even though it's neutrally buoyant.
In the submarine.
Yeah.
Yeah,
You're not very good at this, Chemo. You're not very good at this.
There would be
It's pretty funny.
Because so Kimo, here's how I can answer your question for you. If everything was relative density, then the boat would have the same, or the submarine would have the same density as water.
When
there
you say I'm not sure where you're going with density. What do you mean by that? What's the calculation for density?
I just want to see if you know anything about density, or at least want to concede anything about
Well,
density.
I want you to answer.
All you're answering is that you don't know anything about anything.
What is the calculation? You tell me the calculation for the submarine then.
Okay, the total volume it encapsulates divided, or no, sorry, the other way around. The total mass, or weight, if you want to use that.
Weight,
but
what
the
weight?
The total mass of the boat divided by the total volume of the submarine. That would be the density of the submarine as a whole.
But there are no forces involved here.
So if it's neutrally buoyant, as in it's not going up or down, that means that it is equally being pulled up as it's being pulled down by its weight. Yeah, equally pushed up as it's being pulled down by its weight. So the buoyancy is equal to the weight, and therefore nothing happens.
Well, that's what I just explained to you. There's no forces at play here.
There are, Chemo, but they just cancel out. That's why you have no movement.
What forces
are you
at
saying?
play?
Are you saying that? So the forces at play are, like I said, weight and buoyancy.
Weight? What do you mean weight? When it's at equilibrium, it has no weight. You cannot weigh it. The weight is not affected when it's in equilibrium.
The way what we call weight is how much it will press when it's in normal medium, like air.
But
not underwater.
there is no pressing once it's in equilibrium.
Okay, so you're saying there's no pressing when it's in an equilibrium, and what's sorry, let me think about how to word this.
Okay, take your time.
Hey, Gummy, real quick, what you need to realize.
Oh, here comes the help. I thought he got me. I thought he had me tied up in knots here. Let him think about it and let him come back.
Gummy, you have a container of water on a scale. Now you take an object that's of such density that it will be suspended in the water. It doesn't sink. It doesn't float up on top of the water. It's just in the water. It's buoyant in the water. Now, the weight that you have added to this system will not register on the scale because it's at equilibrium.
What are you helping him for?
According to your guru.
I thought I was getting destroyed by Gummy.
Chemo is obviously correct here, right?
Why are you helping him out here?
I
thought I was being twisted in knots.
We want to attack or anything, is it?
So Gummy, you've just been destroyed. What forces are you talking about?
A practical demonstration.
Yeah, you carry on helping him.
While at equilibrium, and the rude cunt Chemo can't avoid but to overtalk me
Yeah, because Gummy was supposed to think about his answer for a second or two and then come back with a response. Not sit there getting help from you because he's caught in a corner that I was supposed to be in.
He was silently thinking.
So go on then, Gummy. What have you thought about in your silence?
To avoid the silence, Chemo.
Yeah, it shouldn't take that long. Being as I don't know what I'm talking about. He just said, you decide you don't know what you're talking about. I'm trying to show you, Chemo, that you don't know what you're talking about.
And you are the supreme authority. Then I'll just say, why the fuck is anybody here dealing with this?
Yeah, he just said, I'm going to show you, Chemo. I don't know what you're talking about.
But you don't use
Why isn't he showing me? I don't know what I'm talking about.
Why are you such a pedantic little cunt?
Because people say silly things like, I'm going to show you, you don't know what you're talking about.
Well, you were wrong,
so I'm still waiting for you to show me that I don't know what I'm talking about.
Being in equilibrium does not mean it doesn't add weight to the system.
Yeah, it's like that shark that floats in the middle of a room. When it's in the middle of the room, just floating like a balloon, there are no forces acting on it. It's in equilibrium. It's just floating there. You add more density, it will fall. You add less density, it will rise. Very simple.
Still has weight.
Not that you can weigh without a container or a surface. So, Gummy, back to you. Where are you going to show? Why is Curved arguing for you? Show me. I don't know what I'm talking about.
Yeah, we're getting there.
Oh, we're getting there with Curved.
I just needed a second to think about my language because it's not my first language.
Good excuse.
Okay.
Got perfect English. Show off about it. Let's get it.
Okay, fine. Thank you very much. So, do you agree with me that the density of the boat, as in the total mass over the total volume it encloses, is the density, and that would be equal to water if it's neutrally buoyant? Because the relative densities are zero, as in they equal, and therefore it won't go up, it won't go down, right?
Nothing's acting on it.
That's fine if you want to see it that way. But you agree with me there, right?
No, because you're trying to say there's the force acting on it.
Okay, if I were to say you don't have to say there's a force acting on it, I just want to know if you agree.
Okay, fine. So where does the weight come from?
So what I'm asking is that when I say the total mass, so not the weight, not how much it'll be pulled down or anything, just the total mass divided over the total volume. So how much stuff is in that thing?
Yeah. Mass invokes attraction, no?
No.
No? Okay.
Mass is just a property of matter. It's how hard it is to push it.
Yeah, well,
inertia. If it's got a lot of mass, it'll be hard to push it.
Okay.
And so if you have all this mass in a certain volume, that's the density. Do you agree so far?
Yeah, so you've got more density. Yeah, okay.
Okay. And then do you agree that when it's neutrally buoyant, it's not going up or down, then it must have, it's in equilibrium, then it must have the same density over the whole submarine as the water around it, right? Because if the relative densities are zero, they're the same density, it's in equilibrium.
Yeah, it'll have the same density, but it doesn't mean that it has weight.
That's fine. So they're at the same, they have the same density. It doesn't mean they have weight. Okay, that's fine. Now, what I want to know is, how do we do this with a boat? How do we figure this stuff out with a boat? So when you put a boat in the water, how do you tell this density of the boat? How do you tell how much is enclosed?
What kind of boat? A wooden boat has got lots of air in it. That's why it floats.
Let's just say a wooden boat. How do you know?
What?
Yes, let's just say a wooden boat. That's all fine. Just a normal wooden rowboat. So we put that in the water.
Yeah. What do you want to know?
Or we're gonna put that in the water. So it's right now. It's on the dock. It's on a dry dock. So we're going to put it in the water.
Well,
we want to know.
I'm not going through your mathematical equations. I'm trying to figure
out.
I'm not. We don't have
density. No, we don't have to talk about. We don't have to talk about math or equations. I'm just asking. We have this boat here, and I want to kind of think. okay, if I put this in the water, is it gonna sink or not? And so in the example with the submarine, we could think about, okay, the total volume it encapsulates and the amount of mass. Can we do that with a boat?
Yeah, you add more mass, you make it more dense, it'll sink.
Okay, so we have mass of the boat. You agree there? The boat will have mass, the wood and all anything that's in it. That's the mass. How do you know
I
that?
don't get what you were getting at. We were talking
I
about
know
things
because
falling or
we're
not.
doing one thing. Yeah, we're doing one thing at a time. So we agree that it has a mass, a specific amount, because it's not just gonna suddenly
Lot of matter,
lose
yeah,
or gain
lot of
any.
matter, yeah.
Yeah, and then when you put it in the water, then when we want to know the density of the boat, how do we tell the density of the boat? So in the submarine example, we had the amount of matter, so the mass, divided by the total volume enclosed. Can we do this with the boat?
Give me a headache. Just make your point.
Okay, so the point is that no, you can't do it with the boat because the boat doesn't just encapsulate area or air in the same way that a submarine does. The one important part is how much water is displaced and replaced by air. So it's only the part that's replaced by air underwater in the boat, under the water level in the boat, that's actually contributing to the so-called density, not the total amount enclosed by the boat. And this instantly shows that it has nothing to do with the density of the object.
Yeah.
It has to do with how much water is displaced.
I think that's what
proving that what you're saying is incorrect.
Yeah, I think that's what you're trying to do, is show that there's a force at play, but we've already demonstrated.
No, all I'm needed to show, and all I've showed so far, is that relative density and the density of an object is not what can predict whether it will sink or float. It is the amount that's displaced.
Depends on the medium, dummy, as well.
No, we can do this in any kind of medium, and it will have the same effect.
Oh no, it depends on the medium.
The answer of what the medium is will only change whether it will float or not. It will not change the fact that for a boat, it is not the amount of air enclosed by the boat, it's the amount displaced on water. It is proving that it is not the density, it is the displacement of water, proving that you are wrong.
No, because if you add more density, it sinks.
No, you're not adding more density, you're adding more mass in the same volume. And yes, you can say, hold on, you can say that that's increasing the density, but that's just an effect of having mass in a volume.
Yeah, but you want the boat to go down, right? Like a submarine.
No, we're just talking about whether the boat will float or not. And that's not dependent on the density of the boat, it's dependent on the displacement of water. That's what this proves.
No, it's to do with the density of the boat.
So if it's due to the density of the boat, then how can you calculate the density of that boat? Can you tell me? How do you know what the density of that boat is?
I don't need to know how much density. I know that's the cause of why.
So you don't have to know anything about density. You just have to believe that density is the cause of this.
Well, no, dude, you could just find the weighted average of the materials and then do it like that. It's not that hard.
Okay, so you're saying that you get the density by taking the weighted average of the material the boat is made out of?
Yeah.
Well, then, if it's a wooden boat, and we're saying we got to assume that this stuff sinks to begin with, the wood that it's made out of, because why make a boat if the wood already floats? Then
it's not making any sense here, Gummy. They've got lots of air in it. That's why it floats.
All right, let's
My
make this
question for Gummy is...
So here's the thing, though, is if it's got lots of air in it, where does that come into the question? Because you just said that it's the weighted average of the material.
So are you telling me then, if I sucked all the air out of that boat like a cork, is it going to float or sink?
It would still float because
No,
it's about
not.
because it's about the displacement of water, not the fact that it's air in there. It's the ratio
that's the
of
reason why.
mass.
That's
The
the reason.
ratio of mass to displaced water.
No, it's the air that keeps it up.
No.
I mean, do you reject relative density in general, or do you like? I don't understand your position.
So the problem here is that if you want to say that relative density is the reason why, for example, boats float and other things sink, then when you apply that to the scenario of a boat, so something that is partly below, partly above the water, then how do you calculate the density
Have
of
you
that
not
boat?
seen, Gummy? Some would sink like in a tank. Some would float.
Yes,
Some would sink.
and that's why I said we kind of have to assume that the wood is the kind that sinks, but we can just replace this with no problem with a metal boat or an aluminum boat or whatever you want.
Same thing.
And no, because you're not gonna get it to float in water on its own. It's only when it's shaped into a boat shape that you get it to float, because it's displacing water because of that shape, and therefore you get a ratio of mass to displacement that's
Yeah, but
beneficial.
without the air, not going to float in the boat.
No, it doesn't have to be air. It can be nothing. It can be helium. It can be sulfur hexafluoride. It can even be wood. It simply has to be anything that keeps that mass to displacement ratio on the good side. Because if there's more mass than you have displaced in water, you're gonna sink.
Nuh-uh. I'm going to show you this this video here.
Okay, you can show me a video, but I know you're trying to say that you'll never do math and all of this, but the main question is, how do you tell the density of that boat? How could you ever know the density of a boat?
I'm not working out, a model or any calculations.
Yeah, you don't want to know anything about what the density of the boat is. You just want to claim that it's the density that does stuff.
No, I'm claiming cause and effect.
Yeah, that's what I said. You're just claiming that density does stuff.
No, we're
You don't
demonstrating.
even tell us.
We're
You
experimenting.
don't even tell us what the density is or how to know it. You just say that it is.
It's irrelevant, that's why.
So, but the question, Kima, is if we can't verify and test it ourselves, then why are we supposed to believe you when you just say it happens?
I didn't say
if you can't but you can't even tell us what the density is.
I don't need to tell you that. I just need to experiment and show you cause and effect.
Well, I see you're sinking wood with floating anvil. So, how do you explain that, Kimo?
Yeah, the anvil doesn't sink. Why? Because it's relative density. That's what I've been explaining.
You asked somebody to stop talking because they were giving you a headache. Does that work? Chemo, please stop talking. You're giving me a headache.
Can be a headache. Yeah, Gummy's just trying to get me to calculate his world, and we don't have a model.
I just want you to concede that you can't talk about the density of a boat. That you have you have shown and told us that you have no concept of the density of a boat. It doesn't exist in your world. You wanna talk about the effect of it while saying it doesn't exist.
And you can make no predictions. You can make zero predictions. You make zero predictions.
We'll do the practical side, Gummy, and if you want to calculate it.
So the second you can tell me the density of a boat, or even how to know anything about the density of a boat, that's when you can say something about relative density and the density of a boat. But and whether it will sink or not. But
so
when you think that you can't know anything about the density of a boat, then you can just do what you want.
The same thing for gravity. Unless you can show bending of space-time, manipulate it, show an effect, well then you shouldn't really talk about it.
So now you've switched the burden of proof.
No, I'm not switching anything. I'm saying that
you even switched topics.
You're saying because I don't have a calculation, I can't talk about relative density. That's not true. We have an experiment.
No, because you don't even have a definition for it.
We have an experiment, Gummy.
But you don't even have a definition for the word.
Relative density disequilibrium.
Density. Can you define density to me?
relative density to equilibrium here.
Yeah, but so part of that word is density.
Is tightly compact molecule, matter or mass, however you want to describe it. Less air, then it's more dense.
Okay, you can't use the word within its description or definition, Chemo.
Yeah, I'm saying to you.
Could you define the word density for me?
I just have.
No, because you used the word itself within the description. You used the word denser. You can't use the word denser
I didn't.
in
I said
defining
to you,
density.
how many molecules are tightly packed in a substance or in an area or in an object?
In an area or in an object?
Not an area, in an object or a substance.
In an object or substance.
Yeah.
So if I have a ball of coal, can you tell me anything about that density?
No. All I know is that there is a.
So all you know is there are molecules in an object.
I know it's compact, solid. That's about it.
So to you, density is just molecules in an object.
It's just
what if you have what if you have another object that's really big, and one object that's really small,
really big,
but they have the same, but they have the same. No, it's so. Let's say it's completely gold. It's 100% pure gold. You have one that's really big and one that's really small. Well, the one that's really big has a lot of molecules in an object, and the one that's small has a lot of or fewer molecules in the object. So then they'd have different densities to you. Do you agree that these two objects would have different densities?
No,
because you said it's the amount of. But you said it's the amount of molecules in an object.
Yeah. So that smaller object came from the bigger object.
No, they're completely separate objects.
But the same thing, both gold.
They're both made of gold.
So both
but one has more molecules in it.
Tight compactness, degree of compactness.
But what you said is molecules in an object. One object has less molecules. Another object has more molecules.
But the gold itself is tightly compact. Yeah.
You can call it tightly compact if you want to.
What?
But by your definition of molecules in an object.
Yeah, but they were both sync, weren't they? The big one and the small one.
Yeah. So even though they have different amounts of
even if you made a boat of gold and shaped it like a ship, would that sink or float?
So you said molecules in an object?
No, answer my question. If we make a boat, big giant ship made of gold, will that sink or float?
It very much could.
What? Float?
Yes.
A boat of gold, a gold boat.
Yes.
Absolutely.
How would that float?
I know it's insane how that could work out.
Show me how a gold boat can float.
But now we're switching the argument. I still want to understand.
Because the point of a boat...
because you still haven't answered me. Because you said molecules in an object. We have two different objects, different amount of molecules.
Yeah, so both gold...
And yet, why will they act the same if they have different amounts of molecules?
I've just explained to you. Both objects will sink. That's not a gold boat, Jam. That's gold painted.
But how do you know that if they have different molecules?
That's a gold painted boat. I'm talking about a solid gold boat.
Solid gold?
Yes.
No void in between.
Solid gold.
That's not a boat.
Well, then it wouldn't be a boat. It wouldn't be a boat anymore. It would be a brick of gold.
Yeah, if we forged a boat out of solid gold, would it float? Big or small?
Well, if I'm going to call it a boat, then it's going to be hollow inside.
Yeah, so you can make that gold boat float.
If it's hollow inside, absolutely.
Demonstrate that. Let's see a gold boat float of any shape, any kind, any way, any form. Full solid gold.
So Kima, will you concede then
don't-
that you can't tell us anything about density
That just
or
proves
even
my
define
point
it?
now then, because it shows you if that gold is tightly compact, solid, no air, it's going to sink, regardless of the shape.
No, that is not what we agreed on.
Demonstrate that
As
a gold
on top
can
of that,
float. Solid
on top
gold,
of that, you've made a
painted gold.
claim that density is amount of molecules in an object. And I just gave you the example of two objects.
Yeah.
They have different molecules, and yet they will act the same in mediums.
Yeah, that's right. Yeah.
So how come your definition for density has them being different densities, and yet they will act the same as if they have the same density? How do you figure this out?
Because if you were listening, it's relative density disequilibrium. So depending on the medium is key. They'll get a different effect.
So a small ball of gold will have a different effect than a big ball of gold, depending on the medium.
The same effect. That's the
So
point.
why will they have the same effect if they have different densities?
Because it depends on the medium they're in.
You're not. So if they have the same, they have a different density, but they'll have the same effect. And you're saying it's because of the density disequilibrium.
Because of the medium that they're in, yeah.
Who said they were in a different medium?
They're in two different mediums.
That they're in the same medium.
Mm-hmm. They have the same effect.
And they're acting the same. And yet you've said that they have different densities. So how can they have different densities but act the same?
Gold itself has a density. Now the size of that gold.
Okay, so how do you? So when earlier you said density is molecules in an object, and now you're saying that gold has a density. How do you define the object?
Silver has a density.
How do you define the object of gold? Because you say molecules in an object, and now you say that gold has this density.
Yeah, gold is dense. You can figure out if this metal is more dense or less dense than other metals.
No, so you said that gold has a density.
Yeah.
And before you said that, you said density is molecules in an object.
No, density is compactness of something in a substance. Molecules in a substance.
It's compactness. Can you kind of define compactness? What do you mean by compactness?
Like really close together.
So how do you measure compactness? Is it like the distances?
The less air, the more dense.
Well, so how do you measure the compactness of something? Is it by speed? Is it by distances? Is it by a volume? Is it by
They'll just try to see through. If they can see through it with tools or something, they'll figure it out if it's dense or not. That's not difficult.
Yeah, but you said it's compactness, and I just want to know how do you quantify compactness?
Well, again,
do you quantify it with kilograms? Do you quantify it with meters?
What's that table called? There's a table. That's what it's called. Periodic table.
So the periodic table tells you the compactness.
They'll tell you everything you need to know about that metal or that chemical. Yeah.
So where on the periodic table do you see the compactness of a material?
No, I'm saying it will be in a library somewhere or jotted down somewhere.
No, don't talk nonsense.
Yeah, somebody will know the density.
So someone somewhere
has the atomic mass on it and the atomic number.
Are you saying that we don't know the density of gold? Tell me about it.
No, you're saying the compactness of something.
Yeah, of a substance.
Yeah, so if you want to tell me that it has a compactness of something, then you would need to tell me by the quantify. How to quantify the compactness.
Oh, I mean, again, I wouldn't know how they look into gathering how dense something is, but one way to know is just by dropping it or put it in the medium and see what reaction you get. And it depends if you want to compare it to other dense objects. Is it more dense or less dense? So one way you can know is putting in different mediums. Does that help you out?
No, because we haven't really gotten anywhere. But apparently Phil wants to get in and see something.
Oh no. Okay.
Oh
No, it's all right. I just heard nonsense beyond belief and had to clear it up.
Well, we know the density of different metals, right? That's the most important thing.
Yeah, but so we do know the density of stuff, but right now we're trying to understand what density even is, and what you said is the compactness.
Compactness.
And and I'm asking, how do you quantify compactness?
You can do it in
surface tension.
You can do it in
So-
degrees if you want.
Would you talk
So
about surface
degrees-
tension there, buddy?
Degrees of compactness?
Mm-hmm.
Okay, so how many degrees of compactness does gold have?
I don't
Wouldn't
know.
those be?
The answer is not, and no, you can't answer that because it's a silly statement to make.
What, the degree?
Degrees of compactness. That is a complete
Is that just another way of
nonsensical
saying
thing.
density? Isn't he just trying to say density, but without using those words?
He's trying to. We're trying to get him to define density, and so far he said it's compactness, and he's saying that you can quantify compactness by degrees.
All right, now I'm lost. So never mind.
Yeah. So I'm trying
can't
to.
do that.
Trying to get chemo. So do you stick by that? You quantify compactness by degrees?
Yeah, but the degree of compactness, yeah, for sure.
Okay, the degree of compactness.
I guess you're using the word degree colloquially.
Yeah. So are you saying so?
What's the
just
formula
just
for degree of
yeah.
compactness?
So just to
What's the
compare
formula?
then, when you say degree, is it the same as like 360 degrees in a circle, or is it degree as in like
The ratio of a solid volume to the overall volume of the material.
so volume?
Oh, shit. Okay.
So it has to do with volume then.
Yeah, use that word.
I don't get your point.
The point is that you've been avoiding the word volume like the plague, but you finally used it.
Well, this is obvious. You're just playing silly games.
And yet you've been avoiding the word volume for the last half hour, Chemo.
I just told you the degree
Why would you do that?
I just told you the degree of compactness. I just said it a different way.
Okay, so the degree of compactness is the same thing as solid volume over total
compactness is
volume.
defined as the amount of solid substance, i.e., the ratio of solid volume to the overall volume of the material. I just said it in a different way.
Okay.
Yeah, that's what I thought he was
Thank
doing. That's what I thought he was doing in the beginning.
Thank you
Yeah,
for
Grim
using.
understood.
Thank
I
you
was
for
just
using
saying-
big boy adult words. Finally,
I
we've
just said it
gotten
in a
somewhere.
different way. Compactness is the same thing, Gummy.
Calling
Yeah,
it
that was-
degrees of compactness is not the same as saying the amount of substance in a volume.
It's
It
the
is
same
not
thing,
the same way.
Gummy. Same thing.
I kind of did. I kind of did pick it up though, like what he was trying to say. But that's just me trying to.
But you're giving a lot of credence to what he's saying.
I know. I am. I know.
Because
when
Grim understands
when
that
I'm
I
trying
was
to
saying the same
when I'm
thing.
trying to get when I'm trying to get a definition, I don't want it to be kind of okay. But so it's fine. But we got there, chemo. We got there, chemo. So it's the amount of substance in a volume, and now we do the fun part, which is we go back to the original question: how do you know the density of a boat? Because what's the volume of that boat, chemo? How do you tell the volume of that boat?
Well, it's commonly expressed in units of grams per cubic centimeter. It can also be expressed as kilograms per cubic meter.
But what is the volume of it?
It
like, do you stop at the edge? Like, do you stop at the edge of the boat? Because of course the boat is shaped like a bowl, so the center of it. So the center of it isn't necessarily a part of the boat. So what's the density of this boat?
Oh, you're just being silly now. I've given you everything
No.
you need.
We've gotten so far, Chemo. Don't give up yet. So we have this boat.
I've given you as much assistance in calculating as much as
No,
possible.
hold on, Chemo. We have this boat here, and you said that density is substance in a volume. So how do you know that? How can you know the density of a boat? How do you know the volume of that boat, Chemo? How do you tell the volume of a boat, Chemo?
Mass of an object is divided by its volume.
Yeah, so what is the volume of a boat?
You tell me.
No, that's the big question, Chemo.
Count the
How
area,
do you know the
Chemo.
volume of a boat?
You tell
Calculate
me,
the area,
said.
Chemo.
I'm not getting into your mathematical nonsense.
Okay, so I can give you, and you can tell me is this true or not. So let's say we have the boat is equally raised on all sides. Okay, so let's say we take a flat sheet of really large paper, and we can just slide that on top of the boat.
Right.
Now, would you then say that the total volume is equal to the amount of air I've just closed in?
Gummy, now we're lost in absolutely what.
Yes, I would say that, definitely.
We're lost in the absolute point of what we were describing. We're talking about.
No, we're talking about density of a boat. Tell me, how do you know the density of a boat?
Look, I deal with cause and effect. Okay, if there's an effect, I look to find out the cause of that gummy. Then obviously, once I've discovered the cause, you can calculate.
But how do you know anything about the density of a boat?
Again, we conduct an experiment.
Okay. Tell me what experiment you do with a boat to know the density.
Well, we just want to know if it's more dense or less dense than the medium that it's in. We change the medium.
So you can only tell
Is that all you
by
do?
changing the medium. That's the only way to measure density.
No. It just depends on if you want to know if it's more dense or less dense than the medium that it's in.
So you're saying the only way to do anything.
If we want
Let's not incorporate surface tension at all yet.
So Kimo, you're saying that the only way to know density is if it's more dense or less dense than a medium. That's the only thing you can know is more or less dense. Those are the only two things you can figure out.
Submarine, for example, and like we'll build one for the first time, and we made one out of wood, we would say, oh, wow, this is not suitable, right? Through experiments, through testing, then you would change the material, and then you would find the right medium, either be equilibrium, go up or down. So that's how we do these things.
First submarine was made out of wood.
No need for any.
So, Kimo, what happens when I stack a piece of lead onto a piece of aluminum? Why don't they? Because obviously lead is more dense than aluminum. Why doesn't it go to the bottom?
It came out. The first submarine was made out of wood, mostly.
And what happened? Didn't last very long, right?
It worked.
Filled up with water.
No.
Of course they would. The wood would have soaked in all the water, and then it would have sunk. They wouldn't have had very long. It depends if they put a lacquer on the outside to make it waterproof, right? Things like that. If you can make it waterproof, then you're good to go. But other than that, submarines that are wooden aren't going to last very long.
Well, so what was the problem with it?
Well, that was the point, is that we used wooden submarines and realized, well, if we want to go down deeper into the water, we need more density. Now, we can't fill up the wooden boat with water. Well, the pressure will burst. Stronger material. You see?
Well, you didn't say anything about how going to higher depths at first. You just said it wouldn't work.
No. Of course, you can just build a quick little wooden device, but I just mean if you want to go down to the deep depths, see? So all that water pressure. So of course, yeah, they would have probably built a wooden submarine. Not very practical. It's like they have their.
No, it was that it was powered by the guy actually just turning a crank instead of anything.
They used to go in barrels over Niagara Falls, but obviously, water can get inside. And not ideal. So yeah, Gummy. Hit me with the equations all you like, but that's not reality. How we understand reality is through experiments with the experimenter. Yes,
The problem here, Kim, I see you can't seem to describe the density of a boat in any way other than
No,
it
I'm not
being more
calculating
or
anything.
less than a medium.
Yeah, I'm not calculating anything. Not a thing.
Yeah, that's
not one thing am I
so
calculating.
that's fine. So all because I'm kind of stuck there because when you're claiming that all you can know about the density of a boat is whether it's more or less than a medium, then we've fallen into such silliness that it's just not even worth talking about.
Yeah, because I'm not going to talk about equations and trying to calculate.
You don't want to talk about
not that
reality
difficult,
because it
though.
would
They're just
show that what
surface
you're saying
area.
is wrong.
How are you going to do that without an experiment, dude?
Because I'm showing that you're logically incorrect.
Oh, so your mathematics.
I don't even need. No, not mathematic, logic.
But no practicality.
What do you mean by no practicality? Are you saying that logic is not practical?
I'm saying you can't use your logic and demonstrate that relative density is not what's going on.
But that is what is
he just
happening
did.
here. You just
I think
don't
he
want
just
to.
did.
You don't want to entertain the
Oh,
argument
what with mathematics?
because
did?
no, with logic, and you don't want to. You don't want to actually talk about it anymore because you know that the logical conclusion that we're about to reach is that it's no relative density. But you don't want to get there, so what you're doing is you've fallen back to this pretend claim that all you know about the boat's density is if it's bigger or less or more or less than a medium.
Let's
which is
look at
just
the
absurd.
practicality of all of this. Submarine, middle of ocean. What do you know about this?
Sorry, say that again.
Got a submarine, middle of the ocean. What does it tell you? In the water.
It's in the middle of the ocean.
I don't know why you want to switch away from boats. Why do you want to talk about
To
submarines?
show you how relative density equilibrium works.
Yeah, but I want to talk about it in terms of boats. Because I'm a boatman, you know? So can we stick to boats?
So if we add more objects to that boat, what will happen?
I don't know.
First, Chemo, you might want to figure out what the surface area of your boat is.
All I know about the boat is that it's more or less dense than the medium. That's all I know.
So
how do I know?
That boat is less dense than the water, yeah, than the medium.
Okay. Okay, next. What do we know? So now we know the boat is less dense than the water.
What else do you need?
What's
So
the
we
next
can
step?
assume it's not a sunken boat, I guess, because you didn't say.
You didn't need to know anymore. What more do you need?
Okay, yeah. What's the next step?
Boat.
Well, that's it.
Okay.
What else do you need to know? That's it.
All right. Yeah, so we know the boat has less density than the medium. Okay, so we're done there?
Now what's next? What are you not sure about?
Nothing. You're just saying that that's all you can know about it.
I'm saying what
Is
more do you want to know about this?
Okay, can I figure out how deep the boat will dip into the water? Like how much of the boat will be above water? Can I know that?
I guess you can work that out.
So how can I work that out?
Yes, you can. I don't know if you can.
Okay, so you don't know.
I haven't calculated.
Okay.
Timo, do you think we could figure out like the cargo capacity of a boat before filling it up until it almost sinks?
Yeah, I guess with that we can work that out. Yeah. Like when the Titanic,
How might you
they
do
had
that?
the lifeboats, and they said we can only fit 30 people in.
No, I'm not talking about
We're
that
putting
capacity.
80.
I'm talking about like how much weight.
Same thing, dude. Want to know how much? That's the density. Relative
Well, if
density.
I'm shipping lead or something, something tells me I'm not going to be able to fill it up as much as if I'm shipping aluminum.
So Kim, just on that point, I'm not deviating away. On that point, can I? So we know that the boat is less dense than the water or the medium. Can we have any way of knowing how much we can put on that boat before it sinks? Like how many people or how many
I'm
footballs?
sure there's some mathematicians that work that out for sure.
Okay, so there for sure might be some mathematicians that can work that out, but you don't know. How?
Oh, why not? Why not?
I'm pretty sure there's some
Okay,
fifth graders that can work it out.
Oh,
But
sure,
I thought the only thing we could know was whether it's greater or
no,
lesser
no.
density.
So that's scientific. Now, if you want to do a calculation, measurement, now you're free.
Okay, okay.
Science is done. We know cause and effect, so now it's down to you, your department, to calculate. That's what we do as scientists. You would never know that it was relative density unless science, right?
You want to come over here and explain the
Now,
buoyancy
all you
calculation
had
to
for
this
the
kid?
whole time was equations, Gummy, and that's why you're still thinking the force equation realm.
No, the problem. I'm not even talking about force equations. You can't even define density for me.
I just did how many times?
Okay, I'm sorry, you are correct, but how can you apply that density, the definition of density,
It's
to
the
a boat?
degree of compactness.
Yeah, but how can you tell me the density of a boat?
Got to do some calculations.
Okay, so
No.
I've done some calculations, and all boats have a density of 2.
That's what you're saying.
What are you gonna do now? Because you don't know anything
as
about it.
scientists, we don't need to do anything with that. We move on to the next phenomenon and we look at cause and effect.
Okay, so you measure, you take a boat, you put it on water, it floats, and now you're like, here, mathematicians, this thing floats.
Take it away.
And then you move on to what exactly? Balancing footballs on a stick?
No, then we look at the next phenomena. Answer those questions. Like, why do things disappear over the horizon?
So you're good with just knowing
Science.
if this specific boat floats in this specific medium, nothing else.
Science. That's what science is.
So he moves on to poking a stick through a termite hole to
so
capture termites again.
Science.
Eat
It would be great if we use science to figure out what kind of boat would float in what kind of medium and have kind of a rule for when that will happen. But so far, what you've said is all you get is if it's less or more dense than the medium.
Well, what was your observed phenomena in your next experiment?
So my absurd phenomena is that if I have a bigger boat, but it weighs the same.
Where in nature do you see the boats?
Boats are a human construct.
Yeah, so in nature, where do you see this phenomenon?
You don't see boats being built in nature.
Exactly.
Naturally.
Well, actually, in the natural world, boats are already in the natural world.
So you're saying, so
okay.
Kim, are you saying?
No,
Because now you,
no. A tree falls in the lake.
No,
it
this
floats,
is very important, Chemo, because you just said that boat is a human construct. What does that mean? Does that mean we can't do science with it?
Yes.
Hold on a second.
So we can. So what about the science? No, hold on, Kit, please. Let me finish this, because he just said that you can't do science with boats, and yes, earlier, like just a couple minutes or even seconds ago, you said that you did science with the boat to see if it floats or not.
No. That's different. We were doing.
That's different.
Yes, because we were doing a relative
it's
density
literally
experiment, because we see things floating in
science.
nature, right?
So was that not science?
That's science, Kimo.
You're not
Come on.
listening, are you?
So what was that?
See a tree fall and float in the water.
No,
in
was
nature.
that science? Was that science what we were doing earlier with the boat?
If a tree falls in the water...
No, you're not answering. You're switching to a tree. We're not talking about the tree. We're talking about what you said earlier about putting a boat in water, seeing if it floats or not.
Yeah,
that's what you said.
I can do that is because I've seen a tree in water.
What you said is the scientists are done, pass it off to the mathematicians, which is implying you were doing science.
Yes,
but you were doing this with a boat, a man-made product.
Yes, because we see trees float in nature.
So if you see something happening in nature, can you then test it with a man-made thing?
Yes.
Okay, so that's the one qualifier is you see it in nature. You see something in nature first, and then you can construct.
Now you get it. It's taking you ages to understand.
So okay, fine. So are you saying that a tree floats by the same mechanism as a boat?
Sorry, say again.
that a tree floats by the same mechanism as a boat.
Relative density.
But the problem is a tree is solid all the way through, but a boat is hollow. So how can we equate those situations?
Oh no, that tree is got lots of air inside.
How does a combustion engine ever come into existence then?
So when you say it's got lots of air inside, how does it have lots of air inside? Is it a hollow tree?
No.
Then how does it have lots of air inside?
The tree, the bark, the whole inside. What is wrong with you, dude?
So you're saying that the wood is made out of air?
Not made out of
hollow
air.
tubes.
Okay, so you're saying that in between the wood molecules there's also air molecules.
Throughout the tree there is air, yeah.
So in between the wood molecules.
Yeah, because if you were to, you could squeeze that wood, make it more dense, squeeze out any air or water.
So there's water as well?
Yeah, tree drinks lots of water.
Okay. So do boats have water as well inside of them?
Can do, yeah. Once they're in the water can soak into the boat. Absolutely, yes, definitely.
What if it's a metal boat? Do we expect water to soak through metal?
Where do you see metal in nature? Floating metal in nature.
Okay, so it doesn't have to be. It doesn't have to just be in nature. It has to be the exact same thing in nature. Is that what you're trying to claim?
Where do you see metal floating in nature?
So
I
therefore,
can't
metal
think of
can't
one
float
off the
in
top of
at
my
all
head.
because you don't see it in nature. That was kind of the point I was making. We don't see a combustion engine in nature, but we created one of those.
The problem is that you don't see a boat formation in nature.
No, you see a tree floating in nature.
So if you don't, why do you not see a boat formation in nature?
A boat? Where do you see boats floating in nature?
Yeah, where do you see boats in nature?
We just call it a boat. It's just wood.
Okay, so you call the log that's floating a boat.
We could, but we don't. It's a log floating in the water. But if you sit on it, and you say we had a boat for a tree.
What if I call metal a type of wood? because then I can say I've seen wood float, and metal is a type of wood. Do you think that word has power?
No, wood is the observation in nature. So
are you saying that just because we can call it a boat, therefore it is one? Or it's equivalent to one?
No, I'm just saying we label it that, right?
Okay. So because you label it that, you're now allowed to use the concept of that in science.
Dude, tree, float. We have boat, wood, floats. How? Because it's dense, less dense, density, relative.
The problem is, I'm asking, where do you see a boat in nature?
Oh
now you're saying a tree. Now a tree, last time I checked, is not a boat.
But a water spider is a boat, Takimo.
Water spider. Are they not called boatmen or something? Sure, they call some creature boat. Something.
Yeah, some shit like that. But
okay, there is a boat. I just pictured a boat in nature, and anytime you see a boat, you see it in nature.
Did who painted it? Like, which part of nature painted that boat?
That's not painted, I don't think.
And you see the green leaves? They probably rubbed off on it.
That's the fungi.
And any boat that you see is in nature.
It's man-made.
Yes, in nature.
Well, no, he already said that the logs are boats, and therefore you can use boats in science.
No, it's not about it can be any object that's floating. An egg.
Okay, a boat.
You can say, why is that
a boat?
Why
is that use a boat then?
Hold on, but you said any object now. But earlier when I said a boat made out of metal, you said that's not okay.
any object in nature.
So you have a boat.
Nature.
The world
Like,
is
let's
nature.
define
The boat is
though.
in
The
nature.
natural world, or
Oh,
supernatural versus natural. Is that the nature you're talking about, or
talking about man-made?
man-made is natural? By the way,
um,
we're from nature. We're in the natural world. I mean, I'm just saying, like, I don't understand the point of nature or natural world, or
Witsy
because anything we
Lemon,
do is in
Jeremy, if you're
the natural
listening,
world.
get in here.
In my understanding. I mean,
Not
we've all seen a
understanding
leaf
relative
float
place.
on the water, right, with an ant on it. There's your boat in nature.
No, we
Now
don't
let's
mean
reconstruct
like that.
that. Now we can move on and talk about reconstructing that in a bigger way, right?
Yeah, we
That's all
don't
you
mean
needed.
like that,
One example of it happening in nature, so that then we could work on an experiment together. So now let's move on to the boat. There's your boat.
The gummy.
A leaf floating in water with an ant on it. Boom.
How have we concluded?
Now let's work out the calculations, the surface tension, the density, all the stuff necessary to understand the surface volume, surface area, and amount of weight you can put on that object to keep it separate afloat.
Yeah.
It should be easy, bro. It's a real quick couple calculations, and then we
What
can
happened to
figure it out
Gummy?
and then build a bigger one.
I'm still here.
All right. So
Never mind.
now, when we see something in nature, an apple, an egg, a leaf, a tree, question what's going on. Why is that happening? Yeah. Now we can test it with a boat, test it with salt water, change the medium, you can change the object. Entirely up to you. As long as you don't invoke anything like forces. What?
No, so the problem is, you say we can use a bow, but clearly a bow is not enough for you. It has to be out of a material that you see things being boats of in nature.
No, it can be anything. I just told you, an egg, an apple, potato, anything can.
So so you said the boat has to be made out of something you see in nature.
Boat has. No, it's just.
Because when I made the example of constructing a boat out of metal, you said no, because we don't see metal floating.
Right, where do you see?
Yeah, so I've never seen it. I've never seen metal.
We do. I do have
Where
metal
do you see
formula.
metal floating? Where?
It
Where do we see
colloidal
metal
silver.
floating in nature?
Fine.
Like you're
No,
just walking down.
Colloidal silver.
He'll want it to.
No. You
Float.
can't be anything to
I
do with
understand.
man. It's got to be. You're in the Amazon. You wake up. You walk around. You see something happening.
What he wants is that you wake up in uncivilized, where there's no civilization, and you see it.
You see
and
it.
no, I've
That's right.
never seen naturally occurring metal floating.
Why would you pretend like you don't understand the Earth is flat, Gummy? Crazy.
You might see it in lava.
Because
I'm not sure. It's usually silicates.
Because the problem, Chemo, is that I want to be able to say that a metal bow is still a bow, and I can do science with it. But under your paradigm, a metal bow is unnatural, devilcraft, and shouldn't get close to science.
No, we can do
You do know that lithium, potassium, and sodium are all metals that float, right?
Where?
At a lower
In
density
nature?
than water.
In nature, where?
Yeah, you'll never see potassium in nature.
In Afghanistan.
Well,
There's a
show me then.
lithium
Show where
mountain.
it's floating in nature.
I pictured a boat floating that's made of metal.
It's too reactive to stay there for long, right? It really goes nuts in the chemical reaction in the water.
There you go, Chemo. A metal boat floating in nature. And if you could tell us why that doesn't work. Yeah, you can tell me why that doesn't work. And I think that's the more pertinent thing. Whether it's man-made or natural, by your definition, there's no difference. We can still look at that, test it, see how much it'll carry.
Well, according to quantum eraser, Moyak,
what's that?
There's three categories of items. There's natural, there's supernatural. Wait, what was the other one?
Imaginary?
I think the other one was artificial. That's right. There's natural, there's artificial, and then there's supernatural.
It's kind of
Those are the only three categories. And supernatural was anything that was not physical. So For example, ideas are supernatural according to him, or thoughts.
What Chemo would have to do, though, is he would have to explain why I can't do a test on this boat, this metal boat, this thing that's sitting in the water. We can test it. There's no reason that you cannot do a scientific test on it. If you can explain that reason, then go ahead. But it has to be a reason that results in a bad answer or a good answer.
Yeah, you can test this boat, but as metal, not as a boat. Just for what it is. Just for what it is, yeah.
It is a boat by definition.
Oh, by the way, I heard your bitch ass the other day, Jake.
Yeah, but it's only a boat because we call it that. The idea is that it's an object, and we're testing if this floats, and it does. There you go. So you can do science in terms of, I saw something floating in nature, and I'm testing relative density. That big of a... So as long as we're clear, it's not a force. No forces at play.
Chemo, you're starting to sound like Chemo. What's going on?
The relative density. Space.
The only relative density in here is you, mate.
Not sure, just do an experiment. We've done it for you already and put it online. Replicate that.
I don't have the tenacity. Sorry.
Relative density inside a skull.
Or the inclination, either. No.
Now, obviously, you use that force to explain your heliocentric model.
And you need density of a boat to explain your model, and yet you can't seem to explain it.
What, you want me to calculate?
Even just explain it. You don't even have to calculate it. Just explain what part of the boat is the substance and what part of the boat is the volume. That's all you have to tell me.
Tommy, this is not going to help you.
No, it's not going to help you because you don't want to do it. You don't even want to tell me what part of a boat is substance and what part of a boat is its volume.
Because what we're doing is figuring out cause and effect.
I think
You already told him, by the way, though.
Simple thing to just tell. So why can't you just tell me that? Just what part is substance and what part is the volume?
Don't forget about...
Chemo, I don't mind helping you out, dude.
The displacement of the boat.
It's irrelevant, though.
Displacement,
You're the only one that
It's
wasn't
not
talking
irrelevant
shit
to
about
my
my dead mother the
question.
other day.
Yeah, it's displacement.
Give him answer after answer, and it's not satisfactory.
Because you aren't answering the question. You're just saying that you don't want to answer it.
Do you know what displacement means, Chemo?
Oh, here we go. You see?
That's the over volume ratio thing again. It keeps cracking.
No, I'm just checking.
Yeah, I know.
Just checking.
Break down every single word.
No, I'm just checking if you knew what displacement means. That's all.
What I do is when I realise you don't understand the definition, I post it for you. Okay?
No, I'm quite clear what displacement means. I'm just checking whether you know. That's all.
Yeah. Well, there's no need to check anything. Check you if you're on the globe or not.
Well, because what you're actually talking is it's actually a key word in what you're actually talking about. It's
what we're talking about is evidence for a heliocentric.
Actually, no, you're not.
Yeah. We're going to find out if what we were told is the truth, or if there's...
That's not the conversation you're having with who were you talking to with about that.
Oh, well, that's expired. We've been talking that for nearly 2 hours now. Slightly late.
Oh, see, you've just suddenly decided that expired. Okay, that's fine. Move on then.
Chemo.